Hello students, I hope you all are doing well, and today we will see what is statically determinate and indeterminate structures. So structures are classified on the basis of their forms, how they do carry the loads, how they react to the applied loads. On that basis we have seen the classification of structures. Right, now we are trying to understand a structure on the basis of what type of forces it carrying, and if there are so many forces or system of forces is applied on our structure, will it be possible for us to solve it only with the help of equilibrium equations? Make a note of it, what I said. If the system of forces is applied on my structure, will it be possible for us to solve the number of unknowns with only 3 equilibrium equations, right? So in the mathematics we have seen that there are multiple equations we have solved, and from there, if you remember, we understood very basic concept, that is, how many number of unknowns you have, that much number of equations you should form. Until and unless you don't form the equal number of equations, you can't solve that system. That is the principle in the mathematics, right? Now in this structural analysis, the same principle we obey. Okay, we follow that same principle. What it means? If you are solving the system of force with a structure, and if that structure has a 10 number of unknowns or 30 number of unknowns or multiple number of unknowns, okay, and if you have x number of unknowns, you have to form x number of equations to solve that system, right? If you have 6 number of unknowns, you should carry 6 equations, then and then only you can solve that system, right? That is why here we have classified our structure as determinate and indeterminate. What it is, let's see. On the screen you can see here the statically determinate structure and statically indeterminate structure. What does it mean? So statically determinate is the structure in which unknown internal forces and reactive forces in the structure can be found using conditions of equilibrium alone. This alone words carry very powerful meaning over here, because you can use many number of equations, you can form the equation to solve the system, but if you have 3 equilibrium equation, and if your system, your structure, you can solve by that 3 only 3 equations, if you used and able to solve your structure, able to find all the unknowns which may be internal forces or reactive forces, if you are able to solve those all unknowns, then your structure is statically determinate. Then what I said, your structure is statically determinate, right? See here, I have wrote one mathematical expression here in which I said number of unknowns are lesser than the number of equilibrium conditions. So here I will make one correction, a smaller correction. It can be lesser or equal to. It can be lesser and equal to. So if number of unknowns are less than 3 or equal to 3, you can solve that system of forces with the help of only equilibrium conditions. Now what are the equilibrium conditions? We are continuously using that term here. So earlier we understood that equilibrium equation means what? Summation fx, summation fy, and summation of moment at particular point, right? So if these 3 equilibrium conditions are helpful to know the all unknowns in my system, in my structures, then I will call that structure as statically determinate, right? Next is, I have wrote few examples here. Let's read that. Simply supported beam. Okay, so I'm saying the simply supported beam is statically determinate. How? See here, I have a beam with simple supports and I have a reactive externally applied force W. So how many unknowns are here? The unknowns are two support reactions. Reaction at first support and reaction at second support. So how many unknowns are here? Two unknowns. If two unknowns are in the system, we can solve it with the equilibrium conditions. We can apply summation fx, summation fy and summation of moment at particular point, and with these three equilibrium conditions we can solve our structure, right? And that's why I said simply supported beam is statically determinate, right? Now next, see, I have wrote a three hinged arch. Now three hinge arch is this type of arch. You have three hinges. At two supports you have two hinges. Okay, at two supports you have hinge support at it, and one at the crown position. Crown position is, this is the position where you have seen the keystone. Keystone, if you remember, if you observe, this will be your arch, and at keystone you will get such a stone there, right? Okay, so this is how the arrangement of your arch. The middle one, the long, I will say it is a tapered shape, largest size stone which you placed where, that is the crown position. There you have an extra hinge, then that arch is called as a three hinged arch. And this type of a three hinge arches can be solved by using only equilibrium conditions. Only equilibrium conditions. So yes, three hinge arches are statically determinate. Next is suspension bridges. Suspension bridges, you have seen that suspension bridges are also find all the unknowns in that structure, in that suspension bridges can be able to solve by equilibrium, only using equilibrium conditions. Now how it happens, for that you have to take an example and you have to solve for it, right? Now we will move ahead with statically indeterminate structure. We got the idea that statically determinate means what? Statically determinate, it means only three equilibrium equations alone can help and solve the all unknown forces in my system. Now statically indeterminate structure. What is indeterminate structure? Yes. Here the internal forces and all the reactive forces in the structure cannot be found. What I said? Cannot be found using condition of equilibrium alone. What I said? Alone. Only using equilibrium condition, only using three equilibrium equation as summation fx, summation fy and summation of moment, we cannot solve our structure. Only these equations are not sufficient. We can solve the structure. Every structure we can solve, but only by equilibrium equation it is not possible. You have to take additional equations, and those equations are called as a compatibility equations. But before that, if it is not able to solve with equilibrium equations alone, then it will be a indeterminate structure. It will be referred as statically indeterminate oblique, you can also name it as a redundant structures, right? Next is, now here the mathematical expression says number of unknowns are greater than the condition of equilibrium. It means that a condition of equilibrium, how many are there? 3. So here the number of unknowns are greater than 3, and that is why we can't solve our structure, or we can't find all the unknowns in our structure, right? Next is, I have wrote one note here. You can see that note says to solve indeterminate structure, compatibility equations are used. What I am supposed to use to solve such an indeterminate structure? Compatibility equations. Compatibility equations means what? We have equilibrium equations. We have 3 equilibrium equations. In addition to that, if we are using other equations to solve my system, we will call it as a compatibility equations. Now, how to develop compatibility equations? We will see, because we gonna solve indeterminate structures in our upcoming syllabus. Okay, so there we will understand how to develop the compatibility equation and how to solve or how to approach indeterminate structures. But you remember that adding to the equilibrium equations, you have extra equations. Those are called as the compatibility equations, right? Next is statically indeterminate structures said to have degree of static indeterminacy. What does it mean? See, if I have a structure in which number of unknowns, see here carefully, are equals to 5. So I have 5 unknowns in my system, or in my structure I have 5 unknowns. Now I want to calculate this 5 of the unknowns. How I will approach first? First I will check, will it be possible to solve with the 3 equilibrium equations? Yes, 3 are able to solve. How many are remaining then? 2 are remaining. Those 2 develops the indeterminacy in our structure. Those are the 2 unknowns which are causing my structure to turn from determinate to indeterminate structure. So this extra 2 unknowns here are called it as a degree of indeterminacy. That is how degree of indeterminacy, degree of static indeterminacy is introduced into indeterminate structures. It is not part of statically determinate structure. Why? Because in the statically determinate structures, you already have solved the structure. You already managed to calculate all the unknown forces, and that is why there you need not worry about the degree of indeterminacy. Here in the indeterminate structure, you are not able to solve all the unknowns, and that is why you need to take care of extra unknowns, which is called hereafter as a statically indeterminate, degree of static indeterminacy, right? Now let's see the examples. What are the examples for the statically indeterminate structures? So fixed beam. The very first example here is fixed beam. I will take an example of fixed beam here. See, this is your beam and it is fixed at both the ends. Right. If it is fixed at both the ends, what happens? The degree of indeterminacy raised here. A number of unknowns are get raised. How? Because reactive forces are one vertical, one horizontal and one moment. Second, one vertical, one horizontal and one moment. So as we have seen earlier, that fixed support always come with the 3 restraints. What restraint means? What? We have restricted the movement in vertical, in horizontal and in rotation, or rotation is also restricted. Therefore 3 unknowns develops. Why 3 unknowns? Because vertical force, horizontal force and moments are not allowed. Not allowed means what? That movement in that direction is not allowed. What is the movement in that direction? Vertical movement in that vertical movement in the vertical direction, or vertical direction movement, horizontal directional movement and rotation is totally restricted. And that's why what happened? If you restricted something, reactions will develop. If you restricted your beam or your any object, then it will respond and reactions develop. Therefore, in the fixed beams, you have how many reactions? 3 reactions at each support, at each fixed support, right? Therefore, here you come up with total unknowns or total reactions as 6. And how many equilibrium equations do you have? You have only 3 equilibrium equations: summation fx, summation fy and summation of moment. So these 3 equilibrium equations are not sufficient to solve my beam, right? And that is why the fixed beam are considered as a statically indeterminate, right? Next is propped cantilever beam. So let's take an example of propped cantilever beam. In the propped cantilever beam, you have fixed one end and other end is supported like this. Propped cantilever means what? Basically you have a cantilever formation. One end is fixed and other end is free to move. But here you provide one simple support so that extra deflection will be avoided and maximum maximum load can be carried. Why we provided that simple support? If the loadings are exceeded, the deflection, which should be limited in a certain range, that should not exceed that range. Therefore we have provided a simple support at the free end of your cantilever. That type of a cantilever is called as a propped cantilever, right? That type of a beam, that type of a arrangement is called as a cantilever beam. Now in this beam, if you have arranged forces, if you calculate forces, yes, we were discussing propped cantilever. If I have a propped cantilever with me, in which the diagram is like this, in which if we see the reactive forces, if you calculate the reactive forces here, how many are the forces at fixed end? 3, right? Vertical, horizontal and moment, and one more reactive force here. At support, reaction will develop. So how many unknowns? 4 unknowns. Will it be possible to solve 4 unknowns with 3 equilibrium equations? Not possible. Therefore you need to develop or need to form one additional equation, which is called as the compatibility equation. That is what we called, that is why we called propped cantilevers are statically indeterminate, as well as two hinged arches. Two hinged arches are indeterminate. They are indeterminate. Why? Because see here, two hinge, this is your arch, you have a hinge positions here, right? How many unknowns? 1 and 2. At these 2 supports you have unknowns, okay? But additional equation which gonna help you to solve the unknowns, which is because of the hinge, is introduced. See here, whenever you introduce the hinge in your arch, that hinge allows, that hinge, what do that hinge does? That hinge allows one equation, summation of moment is equals to 0 at hinge. That additional equation help us to solve the unknowns, to get the unknowns. If that hinge is removed and you only place the, if you only place 2 hinges, if you only place 2 hinges, then the number of unknowns are get, number of equations available to solve the unknowns are get reduced, and that is why the 2 hinge arch becomes indeterminate structure, while the 3 hinge arches become determinate structure, right? Now static indeterminacy. See, first of all I said structure is statically determinate or statically indeterminate. If my structure is statically determinate, then okay, we can solve it with the equilibrium equations. But if it is statically indeterminate, it falls into 2 categories. Further 2 categories. Further categories are external indeterminacy and internal indeterminacy. If my structure is indeterminate, is it internally indeterminate or externally indeterminate? That we have to understand. Okay, so my structure can be determinate or can be indeterminate, and if it is indeterminate, is it internally indeterminate or externally indeterminate? That is how we are following the chart, right? Now statically indeterminate structures can be internally indeterminate or externally indeterminate. Let's see what externally indeterminate stands for and internally indeterminacy stands for. So when I said external indeterminacy, we will represent it. Now hereafter, degree of indeterminacy will be represented by capital D. Symbol for degree of indeterminacy is capital D. Now I am dealing with the static indeterminacy. Therefore capital D to the suffix S is used. Capital D to the suffix S is used. Then you have E. In front of S you write E. Why that E is provided? Statically indeterminate. But what type of indeterminacy it is? External indeterminacy. So in what I will say, what this symbol refers to or stands for, it is externally statically indeterminate. Degree of external indeterminacy, degree of static external indeterminacy. Okay, so you can frame it correctly. It is degree of static external indeterminacy. Okay, now how do we calculate it, and what contributes, what causes our structure to be externally indeterminate? So see, it is related, what I said, it is related with the reaction components of supports of a structure. It means that if my structure is statically externally indeterminate, it is because of the support reactions. My support reactions or the supports which I have provided in my structure are not sufficient. What I said, however I have arranged my supports, they are not sufficient. They are not giving adequate stability to my structure, causing my structure to get extra unknowns and which I cannot solve. So that is why this external indeterminacy is said to be caused by external supports. Whatever supports you have arranged in your structure, they are not sufficient, they are not providing adequate supports, and that's why external indeterminacy develops, right? Now DSE is representing the external indeterminacy over here. What is the formula for it? DSE is equals to R minus E minus A. R minus E minus A stands for, R stands for number of unknown reactions. We know how to calculate number of unknown reactions. Then E is number of equilibrium conditions. Number of equilibrium conditions. And A stands for number of additional equilibrium conditions. Or you can say it is due to hinges or due to internal rollers you have provided. Okay, see here, I have wrote one word here. Due to internal hinge and roller, the extra equilibrium equations developed, that represented by A. These are not compatibility equations. Do not misunderstand it. See here, there is a difference. A is a number of additional equilibrium equations developed due to the internal hinge you have provided or the roller you have provided in your structure, right? E stands for number of equilibrium conditions, which are 3, and R is the reaction in your structures, right? Now DSE will be equals to what? DSE equals to reactions minus equilibrium equation minus additional equilibrium equation. So formula is set here. Now I am giving you an idea about the reactions with respect to support condition. If you have a fixed support, even we have discussed this already, in the fixed supports you have 3 reactions. How 3 reactions? Vertical, horizontal and movement. Why 3 reactions? Because in 3 of the directions we are restricting our structure from the movement. Next is hinge support. Hinge support come up with 2 reactions, vertical, horizontal. Roller support, only 1 reaction perpendicular to the roller, right? So only 1 reaction perpendicular to the roller. Then if you have a free end, reaction will be 0. If you have a rigid joints, then reaction will be 0, right? Okay, so that is what reactions according to the support conditions, right? Next is number of equilibrium conditions. Now why we are learning this? Because see, we required a number of reactions, we required additional number of we required equilibrium equations and then additional equilibrium equations. So this 3 data we should have, then and then only we can find a DSE or statically externally indeterminacy, right? To find that whatever data is required, that we are understanding how to find, right? Next is number of equilibrium conditions, E. Now, if the concurrent force system is followed, then number of equilibrium equations will be 2, summation fx and summation fy. But if non-concurrent force system is followed, now you can observe I'm using new terms here, concurrent force system and non-concurrent force system. This is you have already learned in the 12th class in the physics subject. So please go remind yourself what is concurrent force system, what is non-concurrent force system, and accordingly how the number of equations, number of equilibrium equations are changing over here. In the non-concurrent force system, summation fx, summation fy and summation of moment means total 3 equilibrium equations are used. Okay. Next is additional equilibrium equation. So when do I use the additional equilibrium equations, and how I will get to know that for internal hinge how many additional equations are provided. So see here, if you have internal hinge support, then you have to take additional equilibrium equation equals to how much? N minus 1. How many are the number of members meeting at hinge? Number of members meeting at hinge. See here, take a simple example. This is your hinge provided here. How many number of members are meeting there? 2 number of members. Minus 1. Subtract. How many are the equations you will take additionally? 1. How many equations you have taken additionally here? 1. If I have joint like this, 4 members are meeting at a point, 4 members are meeting, and at the joint you have provided internal hinge, then how many additional equation you will carry? So 4 members minus 1, so number of equilibrium equation, additional number of equilibrium equation will be 3 here. Please make a note of it. Next is internal roller. Internal roller, how many number of equations? 2. Always internal roller is provided with the 2 additional equilibrium equations. What are those equilibrium equations? Summation fx and summation of moment, irrespective of how many numbers are adding with that roller. Mostly rollers are always connecting with the 2 supports or 2 members. They are connecting 2 members, they join the 2 members. So irrespective of how many members they are adding or they are joined with, they are always carry 2 additional equilibrium equation. One is summation fx and other one is summation of moment equals to 0. Now I have a note for you. Here the note says, for plane structures, DSE is equals to R minus 3. R minus 3 means what? Reactions minus 3. And plane structure means what? No additional hinge, no additional rollers are provided. For such a plane structure, if you directly want to find DSE or external statical indeterminacy, then you can find it as DSE is equals to R minus 3. What is R minus 3 here? R is the reactions, as our formula says, R is the reaction. What is 3 stands for here? 3 is equilibrium equation. In any case, equilibrium equations remains 3. Therefore, instead of using E here, I have wrote directly the number 3. And additional equations are neglected because my structure is plane structure, right? Therefore, my DSE formula becomes R minus 3, right? Now, I have on the basis of this R value, I have something to tell. What it is saying? If R is less than 3, then the structure is not adequately supported and it is not stable. If the number of, if the R's, R means what? Reactions. Let's take an example of this beam. It is simply supported. How many are the reactions provided in it? Only one reaction. This end is free. Only one reaction. It is less than 3. It is less than 3. 1 is of course less than 3. It means that my R reactions are less than 3. Then what they are saying? The structure is not adequately supported. It is not stable. As you can see, can you place one simple support, and can you rest see here, can you rest a beam upon it? It will fall down. Definitely you cannot rest simply here. You have provided a simple support and you are trying to fix a beam upon it. No, it will fall down, right? But if you fixed it, it can stand in its position. It can stand straight, right? But if you provided simple support, no, it will fall down, right? That is why even R tell us about the stability. R is telling us that if it is less than 3, then my structure is not adequately supported and it is unstable, right? Next is R is equals to 3. R is equals to 3 means what? The structure is determinate externally. It can be indeterminate, but indeterminacy can be of two types, internal and external. So if R is equals to 3, then my structure is definitely externally determinate. It can cause due to internal indeterminacy. Determinacy may cause due to internal indeterminacy, but externally it is determinate. What does it mean? Means whatever supports you have arranged for your system, those are adequate and they are providing stable support to your structure. Next is the R is greater than 3. That time the structure is statically indeterminate. Structure becomes what? Statically indeterminate externally. Indeterminate means what? Supports are provided, adequate supports are provided, my structure is stable, but now due to extra supports you have provided, the indeterminacy, only 3 equilibrium equations are not sufficient. Due to extra supports, the extra unknowns are developed. See here, if I can fix my cantilever beam at one end and free at another end, and still it is able to stand straight. If I provided extra support here to ensure the adequate support, in that case what happens? These causes the extra reactions. That extra unknown reactions can't be found with the 3 equilibrium equation. Though my structure is stable, adequately supported, still not able to find with the number of unknowns, then that state is called as a R is greater than 3, but structure is indeterminate externally, right? Now next topic we will learn is internal indeterminacy. How internal indeterminacy develops in our structure, but we will keep that for next class. Now you make a note of this class and try to solve sums. Take one beam from your book. There are plenty number of examples provided. You can try to solve it on your own. Thank you so much.